So you might be wondering, why are we spending extra time with this number 5? I'm sure when you did your assignment yesterday, you realized 5 can be a little tricky. And it will make more sense to you if we can sort of draw the pictures of ranging these people for the picture, or for the photo, I guess I should say. I also think that if we go through this one, it really gives you a pretty good idea of what is going on in lesson 3. And really, what it is taking a large group of elements and then breaking them up into little groups. So, what happens is each group of elements can be arranged. So, for each group that can be arranged, we will have a factorial. So number 5 is a great, question to go through because it has lots of scenarios and it starts off pretty easy and then does get kind of complicated. So let's take a look at 5A. In how many ways can 4 adults and 5 children be arranged in a single line? So just to demonstrate, I've given us lowercase letters to be the children and uppercase letters to be the adult. And all I'm going to do, I'm certainly not going to try to illustrate every single arrangement. That would take us a few days. But I just want to do enough so that you get the idea. So with no restrictions at all, the A could go anywhere, the K could go anywhere, this B could go anywhere, the C could go any place we want, so can the D. We could pull in the L wherever we want to, and the M, and the Q. And I'm missing somebody, E. So there's one possible arrangement, but there are no restrictions whatsoever. So maybe I'll put this adult right in the middle, and this adult at the beginning, this adult at the end. Put this one in here, and let's go with these children, another child here, another one here, and another one here. So this rearranging these 9 elements could go on forever. Now, what I want you to do with this is realize that we really have, in this case, one group with 9 elements. So because we have one group, it means that we only have one factorial to set up. Okay, seems pretty straightforward, but keep this one in mind as we move ahead to the other questions. In question B, so same question, we still have 4 adults and 5 children that we're arranging in a single line. And our restriction this time is that children and adults are alternated. So again, I just want to give you an idea of a couple arrangements and what that would look like. Now, let's say I wanted to start with an adult. I'm just going to alternate adults and children. You guys are probably already a step ahead of me in realizing, oh, that's not going to work. We have more children than we do adults. So in order to alternate them, we would have to start with a child. So the idea that I have right here, it didn't work. I wasn't able to alternate. So now I realize, oh, I'd have to start with a child. So let's start with child A, adult K, child B, adult L, child C, adult M, child D, adult Q, child E. So there's one possible arrangement. Okay, another one. Maybe I put C Z here, then adult L, adult B, and then child B, adult M. Let's go child E, adult Q, child D, adult L, and I'm missing child A. So again, you see what we're doing here is we're moving them around individually, but because we have these sort of restrictions on certain spots, probably we want to think about it with the fundamental counting principle. So I'd probably start this one out. Well, it doesn't let me move that around like my smartboard does. Let's give this a try here. So I would probably start this one out with the fundamental counting principle. I like this method for any time that there's things happening in certain spots, I like to start off with fundamental counting principle. So I'm going to start off with the children. And I'm going to say, I'm going to pick my first child to go in the photo. So when I pick my first child, I've got 5 to pick from. Now I'm going to stick with the children. I've taken Johnny and I put Johnny in the first spot. I'm going to pick my second child now. There are 4 children to pick from, and I pick little Susie. Now I'm going to pick my next child, the next one, and the next one. Now what I want you to do is look at that group right there. So we've got these children as one group. And if I could organize those or arrange them in lots of ways, the quickest way to do that would be 5 factorial. All right, let's take a look at the adults here. I'm going to pick my first adult, and there are 4 adults available. Now I pick Mr. Jones, and I put him in his spot. I go to pick the next adult. There are 3 adults available, and I pick Mrs. Smith. I say, go in there, Mrs. Smith. Now I pick my next adult. There are 2 to pick from, and then 1. So if you look at just the red numbers, the ones that are there for the adults, 4, 3, 2, 1, that's 4 factorial. So again, here what I'm doing is I've got 2 groups. I've got the children that can be rearranged, and I've got the adults that can be rearranged. And so because there's 2 groups, what I have is 2 factorials. So we see 1 factorial for the children and another one for the adults. Now my trusty calculator tells me that would be equal to 2,880 possible ways to line them up for a picture where the adults and the children are being alternated. All right, so there's 2 groups, 2 factorials. All right, question 5. Not really sure why my ink all stayed, but we can fix it up. So question 5 is getting a little trickier again. This time the adults are together and the children are all together. So what we've done in this case is we've taken and we've made these 2 groups. So remember, each group can be rearranged and has a factorial. So we've got this group of children that have to stay together, and we've got this group of adults that have to stay together. So these right now, what I'm looking at in the big picture is I've got two elements that could be rearranged. All of these adults could go first, and the children could go last. So I'm treating these, this like one element and this like another element. So since there are two elements there, that would be 2 factorial. But there's more going on in this situation. It does not say that the adults must be in this particular order. So let's say that the adults are together. I'm just going to set up a little blank for them. So I'm going to say the adults are going to stay together. The kids are going to stay together. But this particular order of adults doesn't have to stay. It could be Q is first, then L, then K, then M. Or it could be any arrangement. So within this little group of adults, 1, 2, 3, 4, those elements could be arranged 4 factorial ways. And it's the same thing for the kids. So the children do not have to be in this order. So these 5 children have to stay together, but they could be in any order. Maybe they're going to be, oh man, help me. Try that again. Maybe they'll be in this order. Maybe it'll be E, C, A, D, B. But I could go on and on with this because these 5 children could be arranged in any order. So 5 factorial. So what we have in this question is actually 3 groups. And all of those groups can be arranged. So again, I just want to point out to you the children and the adults. There's a group of 2, and they could be rearranged. They could be adults first, children next. So that's our 2 factorial because there's a group of 2. Now within this group of children, those elements can be rearranged. So almost like it's its own little question. How many ways can those kids be arranged? And that's the 5 factorial. And then this group of adults within among themselves, they could be rearranged. They still have to be together, but they could be rearranged. And that's the 4 factorial right here. So I think I've got this a little nicer if I bring it through from here. So we've got the group of children and the group of adults. That's a group with 2 elements, so 2 factorial, and the 5 children could be rearranged, and the 4 adults could be rearranged. Now remember that connection word and means that we'd be multiplying. And when we put it in our calculator or when we write it down on paper, we don't even need to have the multiplication sign. It's just 2 factorial, 5 factorial, 4 factorial. So there's 5,760 different ways we could line these people up for a photo where the adults would be together and the children would be together. Aren't you glad that I'm not trying to do that demonstration by showing them all to you? Holy smokes. That would be a real mind boggler. Okay, and we've got one more example here. Okay, so let's take a look at, oh, for some reason I said this is still B. Let's take a look at, this is actually going to be C. If the adults are all together and the oh man, my bad. Let me fix up this question here. Might even be best just to look in your book here because I did this in a rush. So here we're looking at for C, if the adults are all together. Oh, sorry, I'm on D. Hang on here, folks. Our final one, if the adults are all together. All right, so what this does in this one, it changes our group by a bit. So what I've got here with this little box is I'm showing you that these 4 adults have to stay together. So when I look at this whole picture, I've got 1, 2, 3, 4, 5, 6 elements. Let me show you what I mean by that. So with the adults having to all stay together, let's say those adults are right in the middle. So I have to move them around as one kind of block or one element. And maybe the children, we put 2 children first. Then we've got all the adults. And then we've got the other 3 children. So the children can move around individually wherever they want, but the adults, they have to move around like one big element. So let's try another one. Maybe the adults will go at the very front, and then the kids are going to come down here in any order. Let's go A, D, E, B, C. Or maybe the adults are second from the back. And let's say we put E at the very end because E's been misbehaving. We've got to separate him from the others. And then these other kids, the other 4, they could be in any order. So that's demonstrating why I'm saying there's 1, 2, 3, 4, 5, 6 elements in total. So in the whole scheme of things, there are 6 elements that could be moved around. Now remember what that means is that we're considering that group of adults to be one element. But within this one element, you've got these 4 adults, and those 4 adults don't have to be in this order. Those 4 adults could be in any order. So another example could be, let's say, we put the adults first. And then we're going to put our kids. Let's say maybe we put C, A, B, E, D. So that's considered one arrangement. But if I was to it's not going to let me do this, I don't think. If I had the smartboard, I could do this. Off to the side here, let's go. So instead of having K, L, M, Q, I could have the adults all together, but in a different order. So maybe I have Q, L, K, M. Adults are still together, so I'm still treating them as one element. And then I've got the kids coming in, and the kids, remember, can be anywhere. They move around like individuals. So I can have them in any order. I can have them moving around all by themselves. So in the big picture, what we have are 6 elements. 1, 2, 3, 4, 5, 6. And then within this element, this one where they have to stay together, we have another 4 elements that can be moved around. So when we put all of that together, our solution, we have the 6 factorial for that kind of the big picture, 6 elements that can be moved around, and the 4 adults can be moved around, so 4 factorial for them, and means multiply. But again, we don't have to put the multiply sign in there. 6 factorial, 4 factorial automatically means 6 factorial times 4 factorial and gives us 17,208. All right, so I hope that that kind of helps you with number 5 and also gives you a hand with moving on in today's work. So you can see the assignment listed in, posted on our classroom information for today. There's no new material today, but I'm hoping this kind of clears up any problems that you were having yesterday and helps you move on. Have a great day, everybody.